Okay, so we're just going to look at the tanks on the AU9000 fogger now. So we have the main chemical tank, which is 50 litres with a filler cap here, and it's marked by the label. The second auxiliary tank here is a flushing tank, and that's really for the cleaning material, which is an oil-based formulation. We would have some kerosene in there, or a cleaning material, or if we're using water-based formulation in the chemical tank, we could be using just clean water to flush through. So we'll just have a look at the plumbing arrangement for the tanks. We have the tank outlet from the main tank comes into the valve fitting here, and the one from the flushing tank comes into the valve fitting here. And you'll see that we have two valves on this, both feeding through into the filter, so the liquid is flowing this way. When we want to open the main tank, the valve should be positioned in line with the direction of flow, and likewise if we want to open the flush tank to clean the material out of the plumbing lines, we would just close the main tank and open the flushing tank, which is in the same manner. Okay, so as we said, if we open the main tank, normally the liquid would flow down here and then through the filter. There's a 50 mesh filter there. Underneath is, you would unscrew the filter if we need to change it. Okay, so when the liquid is passed through the filter, it then exits. This is closed always, that's the drain valve, but so the liquid exits here and is then taken into the pump. As we said before, the liquid is coming down this pipe from the main tank, through this open valve here, through the filter, and then will rise up here. Very important that this is a drain pipe here. This has to be closed, so the valve is in the right angle position relative to the flow, and then liquid is fed up over the top here into the pump. So the pump is an electric unit. It's got a magnetic gear drive, and it's a stainless steel pump head. Being a gear pump, it's a proportional pump, so the volume that's pumped is controlled by the speed of the motor, irrespective of the viscosity of the liquid. That liquid is then fed here. There's a small pressure sensor at the back here, which is just to indicate that there is pressure on the output of the pump, and that is fed back to the control unit, which is in the vehicle cab, just to give a visual check that liquid is actually flowing. So if the liquid had run out for any reason, or the pump wasn't working, that pressure sensor would indicate a fault condition on the control unit in the vehicle cab. The liquid then is fed up this pipe up to the main heads. These again, all these pipework are stainless steel with a PTFE liner, so they are compatible with all ULV formulations, irrespective of the solvents which are being used. So liquid is fed from the pump to the manifold, which splits the flow of liquid to each head, and each spray head, again, these are stainless steel units with internal baffles. There's no moving parts. The liquid is fed centrally up to an internal baffle is basically taking the air which has been delivered from the centrifugal side channel pump, the fan unit, at high pressure, and that is swirling in a vortex, and the liquid is being sheared at the nozzle here. We can control the size of the droplets very accurately by the air orifice and the distance as it's shearing. So there's a plume of spray which is formed into fine fog, and the droplet sizes generally are around 20 micron, 22 micron, with a water-based miscible solution, and can go down to about 15 micron with an oil-based ULV formulation. So the heads themselves can be adjusted by these thumb screws, and also you can position on the top the angle of the spray plume. So this means we can have one which is spraying downwards, so you could have a channel at the side of a road where the mosquitoes may be collecting, that you can spray down towards that, with the other one pointing upwards for adult mosquitoes which are in the air space around the buildings, etc. Okay, so this part here is the junction box for the electrics, and what we have here is we have the fuse. There's a 5 amp fuse here, which is a resettable fuse should there be a problem with the control unit. There is a 15 amp fuse which again is resettable. It would pop out if there was a problem with the pump. That could be through a blockage or a fault somewhere on the pump, or even a wiring issue. The important thing here, so is always to check these are actually in position. So these are the two circuit breakers for the pump and the control unit. This one is an important one for calibration, and when we are calibrating the sprayer, we need to actually run the pump but without the fan operating. This is basically, we have a sensor on the air circuit, so when the fan is generating the pressure to feed the hoses, we have a cutout on the pump that if there was a problem with the fan, the pump cannot feed the unit, the atomizer. This effectively bypasses that so that we can feed the liquid to the spray heads for calibration. This is the multi-pin connector which connects to the control unit in the vehicle cab. It should be aligned up, and it's just a simple twist to lock it in position. Okay, so here's the control unit which is in the vehicle cabin. You'll see we have 3 toggle switches and a rotary switch for flow rate selection. What we have here is a main on-off switch, so we can disconnect everything with the master switch. And then the 2 other switches, one to operate when the engine is running, to operate the throttle. So you have an idle position and you have an operating position. And probably you may have heard in the background there is a solenoid movement there, which is actually moving automatically the position of the throttle. So this will be idle and full throttle. And then the 3rd switch, you have the pump on off. On the top here you have indicator lights which are not operating at the moment, but normally when the pump is running and the airflow is running, you would have both lights indicating that everything is working properly. And then we control the flow selection by adjusting this rotary switch. Increasing the number is increasing the flow rate, and there's a calibration chart which is in the instruction manual to give the flow rates. Again, as mentioned earlier, the flow rate is actually set because it's volumetric. It should operate more or less without any influence of viscosity. So you can set the flow rate on an operation that should give a consistent output irrespective of the product viscosity, or if the temperature is increasing during the day and the product viscosity changes, the flow rate should remain the same. So this is an important calibration feature to ensure a consistent output from the unit and a consistent application. Just viewing from the other side now, the essential features here, we have the engine. There's the main key, that's just to switch the main master on and off. Obviously that's engaged, and then everything else is controlled from the unit. Once there's a pull start here, with a recoil starter, once we've started the engine, we don't need to touch anything else. We can then, all the controls can be operated from the control unit within the vehicle cabin. The engine basically is providing the power to this centrifugal fan unit, which is a side channel blower, which produces a high pressure. They're basically very reliable, they're quite maintenance free, and they're quite energy efficient, which means we can use a very compact unit to achieve an equivalent performance to some larger units which are in the marketplace. There's a choke and throttle settings here. This throttle is on the cable, which is operated by an electric solenoid, which will pull the cable in and out when we choose from idle position to full speed operation. Obviously it's a 4-stroke engine, so we have an oil reservoir, a separate filling cap, an air filter with the unit as well. So that's the basic configuration of the blower. If we can look at the blower circuit as well. So looking at the air circuit from the system, you can see here you've got the pulley belt transmission from the engine to the actual blower unit to turn the blower unit. The output from the blower unit is down at the bottom here, and you have an air intake, which you can see. There's an air filter here, which has got a filter body inside. Air is drawn up and into the bottom of the blower, and then it exits at this side. And you'll see here there's a sensor to monitor the air pressure. So this is the air input, and this one is the air output. The air is flowing down here under pressure. This is the sensor, which is into the back of the control unit, which will monitor to make sure that the air pressure is sufficient. Should the air pressure drop, it will automatically cut off the pump, and that's a safety feature. Or if the operator cuts the the engine revs because you're pulling up at traffic lights or something like that and forgets to cut the pump, it'll automatically cut the pump as the air pressure drops. So it's an inbuilt safety feature. Okay, so just to complete the air circuit, you can see there's the outlet pipe. Again, this is a stainless steel manifold, and you've got 2 outlets to the pipe. These are temperature resistant hose tubing, which goes up to the atomizer. So these are under pressure, and again, the pressure is very important for creating the correct droplet size. So that pressure in these hoses we monitor with the air sensor, just to check that it's the correct pressure. Otherwise it'll cut off if the pressure is insufficient. So it means that we always obtain the correct droplet size. And again, as said earlier, the droplet size is between 15, 20, 22 micron size. So they're extremely small droplets, but of the optimal size for targeting flying insects such as mosquitoes and flies. Okay, so we'll just look at the start. So we've got fuel. This is the off position. This is fuel on. The choke, we have on-off on the choke, and that can just be set whether the engine's cold or not. Throttle we don't need to touch, but we do need to make sure that the control unit, which is actually in the vehicle cab, is actually in the on position. Then we're ready to start the engine. Okay, so before we start the engine, I'm just going to explain what we would see in the vehicle cab when the unit is running. And what we're going to demonstrate is when we change the position of the rotary switch for the flow control, we should see an increase in the flow rate and decrease as we turn it back. The other thing we'll be able to see is we have green indicator lights on both the air pressure and the liquid pressure, so those should be operating when the liquid is flowing. What I will then do is cut the air to run it, the engine to run at idle, which will cut the airflow, and you should see that the pump will automatically cut off and the flow will stop. So that's what we're going to demonstrate when the engine is running. Okay, so we have the engine running now, and we're going to put it on full power, and we should see the air pressure light come on. Then I'll put the pump on, and we should see the pump. I'm going to set it at a relatively low flow at the moment, Well, we'll start with the high flow. We should have both lights on, and eventually the liquid will be emitting from here. So we're just going to go through the AU9000. We've got it here on a truck. We've installed it onto the back of the bed here. The nozzle's obviously facing at the rear. Should be as close to the back, so when the tailgate is up, everything should clear, but you should be able to have it quite close to the back of the vehicle. So that's the idea. So we've installed it now with the battery is all connected. We'll just very quickly run through again what the main features are. We've got the main chemical tank, which will demonstrate the calibration filling in a minute. We've got the flushing tank at the back here. Those two tanks are connected through the plumbing circuit at the base here. There's two valves. We open one of the valves and close the other one to make sure we have the liquid flowing through to the pump, and the pump will then cycle the material through the two pipes either side into individual heads. This one here is a drain valve. If you need to drain the system for any reason, this will drain through the system by opening this tap here, and that can be drained out into a suitable reservoir if there's a problem with the pump. So the basic system again, we've got the two tanks at the back here. This is the air filter, which is for the blower, which is providing the air pressure. The air pressure is fed through these tubes. On the other side here we have it's a 10 horsepower engine at the back here with electric start, and we've got on the back behind that is the blower, which is providing the pressure, the air pressure for these two pipes here. This is the manifold for the air pressure. This in here is the pump circuit. So there's a centrifugal gear pump with a magnetic coupling on that, which is delivering the liquid. There's a pressure sensor on that side as well, which will tell us if there's no liquid, and it'll automatically cut. We've also got sensors on the airflow, which will cut off if for any reason there was a burst pipe or something happened and we weren't getting enough air pressure into the system. The heads themselves are stainless steel, and we've got the nozzle. There's no rotating parts, there's no moving parts, so we're using a vertical nozzle, so we're spinning the air to create the shearing effect for the liquid. And a special designer nozzle will give us a very precise droplet size control, which is a fog. Basically we're looking at particle sizes. With a water-based spray we're going to look at about 20 micron, with an oil-based going to be about 15 microns. So it's a very fine fog, as we'll see when we fire the machine up. This is the guard, which is covering the belts which are between the engine and the fan, and that's the basic layout of the system. Okay, so this is inside the vehicle cab. We have the control system. We'll just run through the basics before we start the engine. Effectively we've got there's a master switch which is on here. You can just hear possibly the engine starting. You've got, this is the throttle control. There's a solenoid control on the throttle, so we can switch the throttle from idle to full power. We need full power when we're running, when we're actually fogging, but if we come to traffic lights or something, then we'll switch to idle, and that will actually cut everything automatically, because the air pressure will drop, the sensor will pick that up and cut all the liquid flow off. But that's to operate the throttle solenoid. That's the main master switch. This one is to work the pump, so we can run the system on full power. Once it's running, we can then put the pump in, and then we close the pump while still keeping the unit running on full power. This will flush the system out, clear it of any liquid or material that's in there. There's two LED lights on them. These will be green, bright green, when you have sufficient air pressure and when there's sufficient liquid pressure. So either of those cuts out, we've either got a fault or not enough air pressure or not enough liquid pressure. This would indicate the tank needs refilling. This one might indicate that a pipe had come off or something had gone, or the engine wasn't running at correct speed. And this last one here, this rotary switch, is basically for your flow control. There's 10 positions on there. There's a calibration in the manual to give you the different flow rates. Because it's a proportionating pump, basically that'll give you this more or less the same flow irrespective of the liquid viscosity. So it's a very easy and convenient way to dial your flow. You would just set that normally for the operator, and then he would just switch the master on, bring the engine throttle up to full and engage the pump to be fogging, and then move the vehicle. When the vehicle stops, you just flick the pump switch off. You can leave it running. If you're going to be stopped for a long time, you can just put it into idle. So it's quite a simple control system for the operator, and there's just one connection here. There's a heavy duty connector on here, and then the other cable is obviously connected into the vehicle battery. So we'll try and start the engine. So now, I don't know if you can hear in the back there, we've got the engine. I haven't turned the vehicle engine on yet, but the engine is actually running at the moment. If we put the switch from idle up to throttle, should be engaging now. You should be able to hear that. We've got air pressure on the green light showing there. If I put the pump on, showing us we've got liquid pressure there. I won't fog it at the moment because it's still stationary. That will be the way. Two green lights, we're good to go. I can close the engine. We're coming to some traffic lights, or we're going to stop somewhere we don't want to fog. We just leave it running on that. We don't need to keep turning the engine on and off. And if we want to stop the engine again, we can just shut the engine down from within the cab. So we can do everything here, all on this control circuit, without actually doing anything at the back. Everything's remotely controlled here. Okay, so we're just going to look at how you calibrate. With the flow control, I've removed it from the cabin just for purposes of demonstration. Normally, it's really not necessary to calibrate because you've got it pre-calibrated for the operator. So this would only be just occasional check you would do. You have to do it with the product mix, hence why we've got gloves, although in reality I'm just using water today to demonstrate. But if you were working with chemical, you've got to have the appropriate protective clothing, a face shield, gloves and all these things. So normally it's calibrated, but if you do need to check the flow for any reason, there's a simple method where you don't actually have to have the engine running. You can just have, it's probably best to check it in case with the engine running, because you may get a slight difference in voltage which can affect the running speed of the pump. But I'm just going to demonstrate today with it without the engine running, just because it's quieter and you can hear what we're saying. But what you would do for calibration, you can actually, if you put the pump in the on position, whilst everything's connected, obviously you haven't got, you won't get any pump because the air pressure isn't sufficient, so it automatically cuts out. So down here you have a little bypass. If you can see this down here, this button, the black button here, which is called calibrate. And if you press that button, it will actually, you can hear the pump start up and the liquid will come out the two nozzles. Now you need to do this with some buckets and pipes over the nozzles to collect the spray. Because we're using water today, we're just going to demonstrate quickly how you do the calibration. So normally we would have it set on position, depending on what the flow rate was, you would have to look at the calibration chart. But for example, we may have it position 4, which may be equivalent to something like 250 mil per minute through the system. There's two nozzles obviously. So we can calibrate based on that very simply. If I can hold, and you'll see we'll get liquid, and we can measure that
With a stopwatch, if we measure using a stopwatch, if we time the discharge over 1 minute, so I need an extra pair of hands here, but you can hold it there. But you can time it over 1 minute to actually watch the flow rate being discharged from, and you can check both nozzles. So that really is calibration. It's very simple. This material would obviously go back into the chemical tank, but this is water we're just using today. But we can measure the output. So if we can, we'll just try and measure that again. So we'll put the stopwatch down. We can start that there. In this case, maybe just 30 seconds. So we have to hold the calibration button in as we're doing the calibration. And after about 30 seconds, if we cut out there, we would see we've got approximately 180, so it's about 400, it's probably close to, in 30 seconds we've got 160 millilitres, about 320 millilitres output from one nozzle, so two nozzles would be 640. So again, you would calibrate that according to your vehicle speed, your track spacing, the area you're treating, to get your application rate, which is going to all be in the instruction manual.